So you're going to like these notes because I'm skipping the whole first page. You're welcome. So, yeah, because solving a real world problem.
This one's getting more exciting.
Yeah, I think it's about kayaking. Okay. So we are actually only going to do work problems. Even skipping that part. Work problems. Now, there's kind of an important formula thing that will be helpful for these. Work rate times work time equals work done. For every one of these problems, it is seriously going to be easiest if you set up a little table like this. And it doesn't have to be super fancy like that. You could just go, okay, option 1 or option A, option B, and there's the extent of my table. Okay? But this is seriously going to be the easiest way to solve these problems. What this is these are problems where two people or two machines or something are working at the same time to get something done. Okay? You are either given how long it takes them to complete it while they're working together, or you're given, or you're trying to find how long it takes one of them to do it on their own. Okay? So here's our example. One computer can schedule classes for all the students in the school in 5 hours. So it takes one computer 5 hours to do the job. A newer computer can do the job in 4 hours. If they work together, how long will it take? Well, I'll tell you one thing, it's going to take less than 5 hours and less than 4 hours, right? Because if they're working at the same time, they're cutting their workload down individually, right? So, we're going to say computer A is this guy. And we're going to call computer B the newer guy. You can switch that if you want to. I don't know why you would want to be difficult. Just go in order. Now, when we talk about rate, what I want to say is I want to say that computer A can complete one full job in how many hours?
5.
So one job is fully complete in 5 hours, according to computer A. What about computer B? One job in how many hours? 4 hours. Now, this column right here, this work time thing is always the time that they are spending working together. Do we know that? We don't know how long it's going to take them together, correct? So I'm just going to call this T. And it's going to be the same for both of them because they're working together, and once one stops, the other one's going to stop, right? So it's going to be the same. So that's all the information I need to fill in. From there, I can just do some math. You ready? What is 1/5 times T?
1/5 T.
What's 1/4 times T? So in other words, this is how much of the full job computer A would do. This is how much computer B would do. And if they're working together, together being the plus sign, they will complete one full job. Do you see that? It's always going to be equal to 1 because 1 is your completed job, whatever the task is. So if I were to write this just slightly different, 1/5 times T is really T over 5.
Yeah.
And 1/4 times T is
T over 4.
T over 4. I have a pretty simple equation, don't I? What's my LCD?
20.
So I'm going to multiply each of these by 20 over 1. And what's going to happen? 20 and 5 reduce to 4 and 1. So I have 4t. Yes?
Yeah.
Over here, my 20 and my 4 are going to reduce to a 5 and a 1. So I have plus 5t equals what?
20.
Please tell me this isn't difficult to solve. So, couple questions for you. Do I have any excluded values? Yes or no?
No.
No, why not?
T was on top.
T was on top. There was no T on the bottom. So I don't have any excluded values to worry about. Question number 2. What is my answer representing? The amount of time that both of them are working together. Now, if you asked me how long the computers work together and I said, oh, 29 hours, you would look at me and go, okay, you're a total math nerd. What the heck is 29 hours? People don't talk like that, do they? So I would suggest going to your calculator and just do 20 divided by 9.
20.2.
2.22. That's a little bit less than 2 1/4 hours, right? Because 2 1/4 would be 2.25. So a little less than 2 hours and 15 minutes. Okay? So I would like to see the fraction just because that's the exact answer. And then you can go ahead and round it off to like 2.2 hours. Does that make sense?
Yeah.
Can you re-explain the bottom part? The 4t plus 5t was 20?
This part, what's 4t plus 5t?
Oh!
9t. Okay? All right. Next problem. You ready? All right, this time we're not talking about computers, we're talking about people.
Oh, wow.
Jan can tile the floor in 14 hours. So I'm going to call A Jan. So Jan can complete one job in how many hours? 14 hours. Together, Jan and Bill, so I guess B is Bill, can tile the floor in 9 hours. So this right here is not one job over 9 hours for Bill, is it? It's their time together is 9 hours. Do you see that? Slightly different. Up here, it was the time together that I was trying to find. This one, I know the time together. How long will it take Bill to do the job alone? So what am I trying to find out? I'm trying to find out Bill can do one job in X hours. I don't know how many hours it takes Bill to do a job alone. Do you get that? So what's 1 over 14 times 9? 9 over 14? Yeah? What's 1 over x times 9? 9 over x. So what's my equation? 9 over 14 plus 9 over x equals 1 full job. So once you have these first 4, you're just multiplying those to get your third one, multiplying those to get your third one, and then your equation is this plus this equals 1. Every time. Okay, what is my LCD?
14x.
LCD is 14x. Do I have any excluded values?
0.
Which should make sense because Bill can't complete a full job in 0 hours,
Yeah.
right? He's not Superman. Okay, so I'm going to multiply each of these by 14x over 1. So, right here, what cancels?
14.
And I'm left with what?
X 9. 9x. My bad.
What cancels here? the x's, so I'm left with 9 times 14. 126. And 1 times 14x over 1 is
You called it.
14x.
Oh my god, I called it.
All right, so what do I do to solve this?
You have to.
I'm going to move the 9x.
I said that last 20.
So I have 126 equals 5x.
Yeah.
Divide by 5. 126 divided by 5 is 25.2. Whew. So how long does it take Bill alone? 25.2 hours. He is slow. She can do it in 14, and so here's a little lesson in the real world. If you're trying to hire one of them to tile your floor and they charge by the hour, hire Jan, right? Because you're going to get charged less because it's going to take her less time. Maybe she does a worse job. I don't know. Maybe he does a more quality job. Just things to look at.
Bill's cheaper.
Yeah, or maybe it's
Wait,
because
wait.
Bill is doing a bigger floor than Jan. Too many variables.
Technically, the job should be the same size if we're talking about this.
Okay.
Yeah.
Funny, I know.
Wait,
Okay.
how come
Question?
How come when you're multiplying it by 14, like when you're multiplying the 1 times the LCD, it's 14x instead of 14?
Instead of what?
Instead of 14 over x? Oh, never mind. Never mind.
All right. Happy studying.